Alright guys, here we go with our review for our exam. Looking at number 1 and number 2, we have an exponential function. We need to identify whether it's growth or decay. This is going to tell me whether it's growth or decay. If it's greater than 1, it's a growth. If it's less than 1, it's a decay. So in this case, that's a decay. 6/5 is greater than 1, so that's an exponential growth. Now, how do we graph these suckers? Okay, now we know if I wanted to lift out points, right, we can plug in a value here. So let's say if we plug in -1, we've got -1 plus 1, which would be 0. 3 to the 0. Anything to the 0 is 1. 1 minus 6 is -5. So we have a point at -1. 1, 2, 3, 4, 5. If I plug in 0, I've got 3 to the first, which is 3, minus 6, which is 0, -3. So there's my y-intercept at 0, 1, 2, 3. And then if I plug in 1, I get +3. So 1, 1, 2, 3. So here's my exponential function. Now we know that the domain for all exponentials is all real numbers. The range is going to be y is greater, sorry, let's not write it as an inequality, let's write it as an interval notation. So this is going to shift it down 6 units, so we know that my asymptote is at -6. So we're going to say it's going to go from -6 to infinity. Alright, the end behavior, so as x approaches infinity from the positives, okay, so we're going to positive infinity. As x approaches negative infinity, we're going to the asymptote, which is at -6. My y-intercept we found, which is at 0, -3. The asymptote is at y equals -6. Same thing for number 2. Number 2, we have a decay function. We transform this right 5 units and up 2. So from my parent point 1, 1, we went right 5 units and we went up 2. So right 5. 1, 2, 3, 4, 5, up 2. We should have a point right there. So let's plug in some x and y values. Let's figure out our point. So if we plug in 2 here, I've got 2 minus 5, it's -3. So 1/2 to the -3. We're going to flip that. It's going to be 2 to the 3rd, which is 8, plus 2, which is 10. So we plugged in 2, we got 10. If we plug in 1, we've got 2 to the -4th. And then we add 2 to that. That's going to give me, sorry, if we plug in 3, excuse me. 3 minus 5, which is -2. So it's going to give me +4 plus 2, which is 6. If we plug in 5 right here, we're going to get 5 raised to the, sorry, 5, 1/2, excuse me, raised to the 5 minus 5, which is 0. Anything raised to the 0 is 1. 1 plus 2 is 3. So we have a point at 5, 3. 1, 2, 3, 4, 5. 1, 2, 3. Oh my goodness, right? 1, 2, 3, up 6. 1, 2, 3, 4, 5, 6. And we have a point at 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Bam, there you go. So your decay function looks like this. We know we have an asymptote right here at y equals 2. It's a decay function, so it's going to be decreasing. Like that. Domain, still all real numbers. Range is going to be from the asymptote, which is at 2, to infinity. So that's going to be flipped with this one. Alright, so my end behavior as x approaches infinity, it's going to get closer to my asymptote. Talking about my end behavior is flipped. As x approaches infinity, it's going to get closer to my asymptote, which is at 2. So you notice how here we're going to infinity because it's a growth function. As we're approaching infinity for a decay function, we're getting closer to your asymptote. As we're going to negative infinity, we're going to positive infinity here. The y-intercept, we don't have a y-intercept. So we would say none. The asymptote, y equals 2. Sorry, we do have a y-intercept. Excuse me, if I plug in 0 here, I've got 1/2 raised to the -5 plus 2. So 1/2 raised to the 5, so sorry, 2 raised to the 5th plus 2. So let me erase this. We just don't have any on the graph. Alright, so the point would be at 0. This is 2 to the 5th, so that would be 32. Yeah, 16 times 2 is 32, and then plus 2, which would be 34. So the point 0, 34 would be my y-intercept. All right, looking at number 5, we have a log function. Let's graph a log function. Now we know my domain and range are flipped, so we can go ahead and fill in my range is going to be all real numbers. Okay, my domain is going to be from my asymptote, which is going to be a vertical asymptote now. Okay, now my domain is going to go from 0 to infinity. We'll look at that in a second. Log base 2 of x minus 3, we know that that is going to shift it down 3 units. So my parent point, which is at 1, 0, is going to go down 1, 2, 3. I have a new parent point right there. Right, so I have, let's look at some values here. So if I plug in let's see, 2 raised to the, if I plug in 1 right here, I've got log base 2 of 1 minus 3, which would be 1 minus 3, negative 1 minus 3 is negative 4, so I get 1 negative 3. So 2 raised to the what is going to give me 1, so I'm looking at the log base 2 of 1, I'm plugging in 1 here, so that's equal to x, right? So 2 raised to the x is equal to 1, so 2 raised to the what equals 1, I gave you the answer here. 2 raised to the what equals 1, well anything raised to the 0 is 1, so that's where I'm getting x is 0 here, right? So I've got 0 minus 3, which is negative 1, or sorry, 1 negative 3. 2 raised to the 2, so if I go log base 2 of 2, 2 raised to the base 2 of itself, okay, is going to give me 1, so 1 minus 3 is going to give me a negative 2. Alright, so 1 negative 3, bam, there's my parent point. I also have a point at 1, 2, negative 2, there it is. Okay, so my graph looks like this. As x approaches infinity here, f of x approaches positive infinity. As x approaches 0, so we're looking at my asymptote here, as x approaches 0, f of x approaches negative infinity. The x-intercept is going to be at 8, 0. My graph kind of sucks, but it's going to be at 8, 0. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to fix my graph. There we go. And the asymptote is going to be at x equals 0. Bada bing, bada boom. Another log function, we got the log base 1/3 of x plus 2 plus 1. So we know we went here, we went left 2 units. So my parent point's right here at 1, 0. We're going to go left 1, 2, and we're going to go up 1. Bam, there's a point right there. Again, we know my range is all real numbers. My domain goes from my vertical asymptote, which is right here, x plus 2, we set that equal to 0, x plus 2 equals 0, so we get x equals negative 2 as my asymptote. My domain goes from negative 2 to infinity, so negative 2 to infinity. We know my asymptote is right here, x equals negative 2. Alright, let's find some values, so x, y. Okay, I know I'm going to make this. Okay, if I plug in 1 right here, I get log base 1/3 of 3. So that's going to give me, if I plug in 1, it's going to give me 3 plus 0, which is 1, right? So if I have a point at 1, 0, bam. Okay, I have a point, if I plug in negative 1 here, I get the log base 1/3, okay, of negative 1 plus 2 is going to give me 1. So 1/3 raised to the what is equal to 1, so it's going to give me 0 here, plus 1, which is 1. So I have a point at negative 1, 1, negative 1, 1. Bam, there it is your parent point. Alright, if I wanted to find my x-intercept, there it is, 1, 0. Okay, so I have enough points. Let's go ahead and graph this puppy. Alright, as x approaches blank, the graph approaches infinity. Well, as x approaches my asymptote at negative 2. As x approaches positive infinity, it goes to negative infinity. Alright, looking at how to write in exponential or log form, 8 squared is equal to 64, so we would write the log base 8 of 64 equals 2. The log base 2 of 32 equals x minus 4. The log base 10, I don't have to write it, of 54 is equal to 2x. We have the natural log of x minus 2 is equal to 6. Same thing here. Okay, we have a natural log here. This is base e. So e raised to the 38 is equal to x. Oops. Log base 4. So 4 raised to the exponent of x is equal to 90. X raised to the 1/2 is equal to 7. And 3 raised to the 3rd is equal to 27. Now let's evaluate these suckers. So we've got 9 raised to the x equals 81. So we could write 81 as a base of 9. So we'd have 9 raised to the x equals 9 raised to the 2nd power, so x equals 2. 81 raised to the x is equal to 3. Alright, so we can write this as a base of 3, right? So 3 raised to the 3, x is equal to 3 raised to the 1st. So 3x equals 1, x equals 1/3. 1/4, sorry. This is 4. not 3x. Coach Sapp, I don't know what you're doing. Alright, we got 5 raised to the x is equal to 1 over 25, so we know x is equal to negative 2. 6 raised to the x is equal to 1. We know anything raised to the 0 is equal to 1. Bam. 10 raised to the x is equal to 63. Okay, I'm going to leave it like that because you don't have a calculator. Same thing, 7 raised to the x equals 95. So I'm going to leave it like that. 2 raised to the x equals 78. And e raised to the x is equal to 42. Just rewriting those in a different form. Look at some properties of logs. We have the product rule, the power rule, and the quotient rule. Alright, so let's look at how to use these suckers. Okay, I can rewrite this as the log base 2 raised to the third power. It's the power rule. Plus the log base, the log of x minus 4. So now what I can do is I can multiply these. 2 raised to the third is 8, right? So I can say this is the log, same log base, so log of 8 of x minus 4. So that'd be the log of 8x minus 32. Same thing here. Okay, I've got the log base 5 of 324 raised to the 1/2. Okay, and then I'm going to divide by 2 because that's what the quotient rule tells me. I'm going to subtract, right? So this would be the log b of m minus the log b of n. Same here on the power rule. We bring that out in front, so we'd have n times the log b of m. The product rule says that these two are added together, log b of m plus log b of n. So those are my rules. Just a quick reminder, 324 to the negative, to the 1/2 over 2. We write it like that. So we have the log base 5 of 9. Same thing here. Okay, I've got the natural log of 6 to the third, right? I'm going to bring that as the exponent. And it's divided by, so we'll divide by 4 raised to that. That's the exponent also, so 4 raised to the 3/2. Okay, now it's going to give me the natural log of 27. Log base 3 of this sucker. Okay, so what we're going to get is we're going to get the log base 3 of x to the 6th, y to the 15th. Okay, now we can write that as 6 log base 3 of x plus 15 log base 3 of y, right? We can expand it out. Same thing, natural log here, so we've got natural log of 2 to the 4th over a to the 12th. So we can say that's the natural log, 2 to the 4th, so we can say that's a natural log of 16. Or you could say 4 times the natural log of 2, same thing, minus 12 times the natural log of a. Alright, so last one, we could say this is the natural log of 4, p to the 3/2, q to the 10/2, or 5. So I've got the natural log of, this is going to bring that in front, so I've got 3/2 times the natural log of 4p. Plus, I can take this 10/2 and write it as a 5, so 5 times the natural log of 4q. Alright, let's solve some equations here. I've got the natural log of 5x plus 7. I have the same log bases. I can set these two equal to each other, so 5x plus 7 equals 2x plus 31. Solve for x, we get 3x equals 24, x equals 8. Natural log of p squared minus p, so I've got the natural log cancels out. P squared minus p is equal to 6p plus 18. So p squared minus 7p minus 18 equals 0. We can factor that. That's going to factor into p minus 9 and p plus 2. So p equals 9 and p equals negative 2. Okay, now negative 2. No, we're good because none of them are negative. So both of those answers are good. None of them are extraneous. 31, we can say this is 36 raised to the 1/2 plus 3k plus 7 is equal to 132. Right, same log bases. 36 to the 1/2 is going to give me 6. Excuse me. This times 6 times 3k plus 7 is equal to 132. So 18k plus 42 is equal to 132. Subtract 42, subtract 42. 18k equals 90, so k equals 5. And last one, I've got 2 log y plus 5. That's going to give me y plus 5 squared is equal to 20 over 5, right? I can write that as a quotient. So this is going to give me y squared plus 10y plus 25 is equal to 4. Now we can bring that to the other side, so y squared plus 10y plus 21 is equal to 0. Factor that, we get y plus 7, y plus 3. So we know we get y equals negative 7 and y equals negative 3. Now we plug those back in, negative 7 plus 5 is going to give me a negative log here. So that's an extraneous solution. Y is negative 3. Negative 3 is going to give me a positive solution here, so yeah, that's my answer. Alright, number 33, I've got 2 raised to the 7th equals 9m plus 2. Subtract 2, so I get 128 minus 2 is 126 equals 9m. Divide by 9, we get m is equal to 14. Here we go, we've got natural log of 2a minus 1, so I can bring that to the exponent here. So I've got e raised to the 3, right? So if I divide this, that's going to give me 3 right here. So e raised to the 3rd, I'm going to say 3rd, is equal to 2a minus 1. Perfect, yep. So add 1, we get e to the 3rd plus 1 equals 2a. So a equals e to the 3rd plus 1 divided by 2. I'm going to leave it like that. Alright, solving exponentials. Okay, here we want to write these as the same base. So base of 4, we can write this as 4 to the 3rd, x plus 7, which is going to give me 3x plus 21. 3x plus 21 is equal to 5x minus 3. So now we're going to get 2x, add 3, 24, x equals 12. Over here, same thing, we got 9w minus 8, so we could write that as 3 squared. W minus 8 equals 1 over 3 to the 3rd. Or I could say, I guess 3 to the negative 3 is what I should say. Right, it's the same base. The 2w. Okay, so we've got 2w minus 16 is equal to negative 6w. And we get negative 8w is equal to negative 16. So w equals positive 2. Here we want to rewrite this. So we got the log base 8 of 48 equals n minus 5. So let's add 5. So n equals the log base 8 of 48 plus 5. Those are not like terms. Do not combine them. And here we've got 3. Well, actually, let's do this. Let's divide by 2. Divide by 2. No, that's not what to do first. Get rid of my 11 first, so let's add 11, we get 2 times 3, 4y equals 72. Now let's divide by 2, how about that? 3 raised to 4y equals 36. Alright, so now I've got the log base 3 of 36 equals 4y, so y equals the log base 3 of 36 divided by 4. Here we got the natural log of 65 equals a plus 1, so a equals natural log of 65 minus 1. And here we're going to add 7, so that's going to give me negative 27, negative 3 e to the 2m minus 5, divide by negative 3. E to the 2m minus 5 is equal to positive 9. Yes. Alright, so now I've got the natural log of 9 is equal to 2m minus 5. So we're going to add 5. We've got m is equal to natural log of 9 plus 5, and then that's divided by the 2. Alright, looking at rational functions for the other part of our review. Let's look at number 1. So number 1, let's try to factor the top. We're looking for the GCF here. GCF is going to be 6x. That's going to factor into 2x minus 5. If looking for the GCF on the bottom, that would be 10x squared, so it's going to be 2x minus 5. So again, we have the same thing on the top and on the bottom. What we can do is we can cancel that out. We're left with 6x over 10x squared. Okay, not quite done because this can be reduced. 6 divided by 10 can be reduced to 3 over 5. X over x can be reduced to an x in the denominator. So that would be your answer right there. Number 2, same thing. GCF in the top is going to be 4, so a squared minus 9. In the bottom we have a GCF of 8. That's going to be 3 minus a. This can be factored further, so this is going to become 4a minus 3 and a plus 3. And this is going to be 8, 3 minus a. Okay, now let's factor out a negative of that. So this is going to be negative 1 a minus 3. Now these will cancel out. So on the top we've got 4a plus 3. On the bottom we've got negative 8. Alright, now this can be reduced. So this is going to become a plus 3 over negative 2. Alright, look in here. We can factor the top. So looking for factors of 40 that combine to give me a negative 13 is going to be n minus 8 and n minus 5. On the bottom, we can do the asterisk method. So this is going to be 3 and 3. My factors of 15 that combine to give me 14 is going to be 15 and 1. Okay, it's got to be a negative 15. So this can be reduced to 1 over negative 5. So we have n minus 5, 3n plus 1. These cancel out, so we're left with n minus 8 over 3n plus 1. Going on to operations with our rational expressions. So same thing here. Let's look to factor before we do anything. So we can factor this. Okay, I'm going to factor it into 2p minus 1 and 3p minus 5. Again, factors of 30 that combine to give me a negative 13. On the bottom we can factor this, factors of 18 that combine to give me 17. So we have, if we do the asterisk method, we got 2 and 2. Factors of 18 can be a positive 18 and a negative 1. So we have 2p minus 1 from this. This reduces to 1 over 9, so p plus 9. Same thing here, factors of 63 that combine to give me 16 is going to be p plus 9, p plus 7. And then here we have 4 as the GCF, so we've got p plus 7. Alright, now let's reduce what we can. So I see p plus 7 in the top and on the bottom. Bye-bye Felicia. I see a p, 2p minus 1. Bye-bye Felicia. So here I've got 3p minus 5 times p plus 9. Here I've got p plus 9 times 4. Oh my goodness, p plus 9, p plus 9. Bye-bye Felicia. So on the top I've got 3p minus 5. On the bottom I've got 4. Answer. Here we go, let's factor this. So factors of negative 2w squared minus 50, that can be factored into 2. Factor out of 2, that's going to be 25 minus w squared. So that's going to be, if I want to take out a negative 2 of that, it's going to be w squared minus 25, which is going to be w minus 5, w plus 5. Here I have an asterisk method. Oh no, sorry. Let's factor out a GCF. So 3 is going to be w squared plus 3w, so w squared plus 3w minus 10. So factors of negative 10, they combine to give me 3, so positive 5, negative 2. So w plus 5, w minus 2 times factors of 14 that combine to give me 5, that would be w plus 7, w minus 2. And then factor GCF here, that would be 6, we got w minus 5. Alright, let's cancel out what we can, right? So I see w minus 5, any w minus 5s in the denominator, yeah, bye-bye. W plus 5, bye-bye, w minus 2, see you later alligator. So in the top, we have negative 2 times w plus 7. In the denominator, we've got 3 times 6, which is 18. Now that can be reduced to 1, right? So we have a negative w plus 7 over 9. Alright, here we go. Factor out GCF. So 5y plus 1, 2, and we're going to flip this. So this is going to become, factor out GCF, the GCF of 8y. Yeah, 8y. So it's going to become 5y minus 4. This is going to go to the denominator. So factor out a GCF of 5. That's going to become 5y minus 4. Oh my goodness. Let's cancel out what we can, right? So those are gone. I can also cancel out the 5s. I can also cancel out the 2 and this. That's going to become 4. So I've got 4y times y plus 1 over nothing. 2 cancel out with that. 5 cancel out with that. Yeah. Bam. There you go. Okay, I guess you could also say that is 4y squared plus 4y. Same thing. Alright, number 17. Again, that's also, no, that's a plus. Is that a plus? No, it's a divided sign. Okay, so let's factor out GCF here. So that's going to become 2. So this is going to become c squared plus 2c minus 3. So factors the negative 3 that combine to give me 2. It's going to be c plus 3 and c minus 1. And then here we can factor out 4. So factors of 12 that combine to give me negative 7. So I'm going to go, that's going to be 4c minus 3 and c minus 1. Now I'm going to flip this puppy. Alright, so that's going to become 16c squared minus 9. That's a perfect square, difference of two squares. So it's going to be 4c minus 3 and 4c plus 3. In the denominator, that's 16c squared plus 48c. I can factor out a 16c as the GCF. We get c plus 3. Now let's cancel out what we can, right? So 4c minus 3, 4c minus 3, c plus 3, c plus 3, c minus 1s, 2 and 16 becomes 8. So I've got 4c plus 9. No, sorry, that's not 9, it's 3. 4c plus 3. Yeah, 4c plus 3. And on the bottom I've got 8c. Now, understand that you cannot reduce this 4 and this 8 because this is a whole thing right here, right? So this is two terms. Both of those would need to be divisible by 8, which the 3 and the 8 don't go evenly. So leave it like this. All right, here we go. I got a minus sign here, so let's make sure we have the common denominator, which we do, x squared minus 16. So we can say this is 6x minus 20 over x squared minus 16. 6x minus x is 5x. Minus 20 over x squared minus 16. So let's factor out our GCF here. So we got 5x minus 4. On the bottom we've got x minus 4, x plus 4. Those go away, so we get 5 over x plus 4. Wait. Ooh. Hold on. This is 6x minus x plus 20. Because minus that whole thing. That's my bad. Okay, so then that would be 5x plus 20 would be plus 4 here. So these would cancel out, and we got x minus 4 on the bottom. My bad, guys. Is there everybody following that? Right, so this is minus that entire thing. So minus x plus 20. Minus negative would be plus 20 here. So when we factor that, would be 5x plus 4. So we'd be able to cancel out the plus 4s. We'd be left with the x minus 4 on the bottom. Alright, here we go. I got a minus sign here. So it's 3. This is 3k plus 5. We can factor that into 3k plus 5 right here. So I need to multiply this by k plus 5. So I've got 16k plus 80 minus 4k minus 56. Right, minus the whole thing. And that's over the same denominator of 3k plus 5. Alright, so now I can combine like terms. 16 minus 4 is going to give me 12k plus 24 over 3k plus 5. Now let's cancel, or let's factor out a GCF of 12. Alright, now last step we can reduce here. So this is going to become 4k plus 2 over k plus 5. Moving right along. Alright, I'm not doing all these. Let's see which one doesn't look like one we've done. Let's do number 14. 14 looks kind of hard. Alright, so let's look at number 14, right? So number 14, GCF, let's factor this, x, so 3 times 1, 3, so factors of 3, so it would be -1 and -3. Alright, so we know we need to multiply this by x minus 3, this by x minus 1. Alright, so this is going to become 3x minus 1 times x minus 3 minus x minus 1 squared plus x plus 1. And that's over x minus 1, x minus 3. Okay, so let's go ahead and multiply this out. We've got 3x squared minus 9x minus x plus 3. And then we've got minus x squared minus 2x plus 1. And then we've got plus x plus 1. And again, that's over x minus 1, x minus 3. Alright, so we've got 3x squared minus x squared, so that's going to give me a 2x squared. We've got negative 9x, negative x, that's negative 10x. And then positive 2x, so negative 8x, negative 7x. We've got 1, negative 1, positive 3. So 3, 4, but a negative 1 is going to give me a positive 3. And again, that's over x minus 1, x minus 3. So now we're here. Okay, now let's factor this if we can. So looking at the asterisk method, 2 and 2, factors of 6 to get negative 7, it's going to be negative 6 and negative 1. So that stays, so it's 2x minus 1. This reduces to 1 over negative 3, so x minus 3 over x minus 1, x minus 3. Oh my goodness, bye-bye. So my answer is 2x minus 1 over x minus 1. Alright, let's look at solving these puppies. Okay, so you can solve them a lot of different ways. What I'm going to do is I'm going to cross multiply here. So let's say this is 3 times a, that's 3a, equals a minus 5, a minus a plus 5 is going to give me a squared minus 3a minus 40. Let's subtract 3a, so a squared minus 6a minus 40. It's a minus 10, a plus 4. That's equal to 0, right? Because we moved that over. Alright, so a equals 10 and negative 4. Alright, looking at this one. First off, let's find a GCF here. So let's multiply this by 2 and this by n. So I've got 3n plus 2, and that's over 2n squared, right? 3 times n is 3n. 1 times 2 is 2. That's going to give me 2n squared. That's going to give me 2n squared. So that's equal to n minus 2 over 2n squared. Now what I'm going to do is I'm going to move this whole thing over to the other side. So let's subtract this entire piece. So it's going to become 3n plus 2. I'm going to do it a different way than I did number 22. So 3n plus 2 minus n minus 2. Right? I move that entire thing over 2n squared. That's equal to 0 now because I moved this puppy over. So now I've got 3n plus 2 minus n plus 2 over 2n squared is equal to 0. Combine like terms here, so 3n minus n is going to give me a 2n plus 4. Now I can multiply this to the other side to get rid of my denominator, and that's going to still be 0. So 2n plus 4 equals 0. Let's solve for n. So subtract 4 on both sides. 2n equals negative 4. N equals negative 2. Alright, moving right along. I say we're good on the solving. Let's do a couple graphing and be done. Alright, so looking at number 26. Number 26, let's graph that puppy. I know that my vertical asymptote is this thing right here. We set that equal to 0, so x plus 4 equals 0. We get x equals negative 4 as my vertical asymptote. Get out a different colored pen. All right, now, judging by this, okay, vertical asymptote is at x equals -4. Judging by this, okay, judging by my degrees here, I know I have a horizontal asymptote at 0, but I went down 7 units, so it's at y equals -7. So the horizontal asymptote is at y equals -7. 1, 2, 3, 4, 5, 6, 7. Now we notice we didn't have any reflections. Okay, so I know I'm going to be working the top quadrant and the bottom right quadrant. So it would look something like this right here. We can obviously plot points into that thing. The domain is going to go, just a second. So the domain, again, domain's x value, so it goes to my vertical asymptote, which my vertical asymptote is at -4. So we're going to go from negative infinity to -4, and that's union with -4 to positive infinity. It's not included, obviously, because it's the asymptote. Range is going to go to my horizontal asymptote, which is at y equals -7, so negative infinity to -7, union with -7 to positive infinity. All right, look at number 27. We can see we have a reflection here. We have a vertical stretch by 2, okay, and we went up 3 units. So I know right now that my horizontal asymptote is going to be at y equals 3. My vertical asymptote, this is equal to 0, so x equals 0. All right, so let's put those on our graph. X equals 0 as the vertical asymptote. Horizontal asymptote, y equals 3. 1, 2, 3. All right, the domain. So if we graph that, we have a reflection over the horizontal asymptote, which would look like this, there and there. All right, now the domain is going to go from -infinity to my vertical asymptote at 0, so -infinity to 0, union with 0 to infinity, and my range is going to go from -infinity to my horizontal asymptote, which is at 3, union with 3 to infinity.